They called it a mechanical monstrosity. Engineers who'd spent decades perfecting steam design looked at the blueprints and walked away. Union Pacific's own board members questioned whether the money would have been better spent on conventional power. The numbers seemed absurd. A boiler pressure that would have burst older designs, a firebox large enough to stand in, driving wheels taller than a grown man. But the big boy wasn't built for elegance. It was built for Wyoming. The year was 1940, and America's transcontinental railroad had a problem that couldn't be solved with existing technology. The Wasatch Range stood between the heartland and the West Coast like a granite wall, its eastward approach climbing grades that made veteran engineers white-knuckle their throttles. Every freight train heading west meant doubling up locomotives, sometimes tripling them, burning through coal and crew hours at rates that made accountants wince. The math was brutal. A standard 482 mountain type could haul maybe 40 loaded freight cars on level ground. Hit the grade east of Ogden, and that number collapsed to 12, sometimes 8 if the cars were heavy. The railroad was essentially running 3 trains to do the work of 1, and the War Department had made it clear. Capacity needed to double, maybe triple. There was equipment to move west, steel and oil and machinery that couldn't wait for the railroad to figure out a solution. Alco's design team in Schenectady worked through the winter of 1940 with a single directive. Build something that could move a full freight consist over Sherman Hill without helper engines. No doubling, no delays. 1 locomotive, 1 crew, 1 run. What they drew looked less like a locomotive and more like 2 engines welded together. 4 sets of driving wheels up front, another 4 in back, all connected to a boiler that stretched over 130 feet from coupler to tender. The wheelbase alone was longer than some entire switching locomotives. Fire crews would need to shovel coal into a firebox, consuming 150 pounds per mile just to maintain steam pressure. Union Pacific ordered 25 of them before a single unit turned a wheel. The first big boy rolled out of Alco's Schenectady works in September 1941, bearing the road number 4000. Workers had chalked Big Boy on the smoke box during assembly, and the name stuck despite official designations. It weighed in at 1.2 million pounds, more than half of that on the driving wheels alone. The tender, fully loaded, added another 500,000 pounds of coal and water. Test runs on level track outside Schenectady showed the machine could pull. The question was whether it could climb. Wyoming answered that in November. The 4000 left Cheyenne westbound with 70 loaded freight cars, a consist that would have required 3 conventional locomotives and an hour of coupling work. The grade began gently, then steepened as the track climbed toward Sherman Summit, the highest point on the original transcontinental route. Coal smoke poured from the stack in thick black columns. Inside the cab, the firebox roared with a sound like sustained thunder. The big boy didn't slow. Mile after mile, it hauled those 70 cars upward through terrain that had broken lesser machines. At Sherman Summit, 8,200 feet above sea level, it crested without losing momentum and kept pulling all the way to Ogden. 1 locomotive, 1 crew, 1 run. Union Pacific ordered 100 more before the year ended. By 1944, all 25 of the original order were in service, working the Wasatch grades with an efficiency that seemed to rewrite physics. Maintenance crews discovered something unexpected. Despite their size and power output, the big boys were easier to service than the aging fleet they replaced. The roller bearings reduced friction. The simplified valve gear meant fewer adjustment points. A single big boy could do the work of 3 older locomotives with less cumulative downtime. But size came with consequences nobody had fully anticipated. Not every turntable could handle 132 feet of locomotive. Roundhouses designed for standard power needed modification, sometimes complete rebuilding. Water towers had to be upgraded to fill the tender's 25,000-gallon capacity. Coal tipples strained under the weight. And then there was the fuel consumption. A big boy on a hard run through the mountains could burn 16 tons of coal in a single shift. The railroad's fuel budget, already tight during wartime rationing, absorbed the shock only because the alternative was running multiple locomotives on the same route. The math still favored the big boy, but barely. The war ended. Diesel-electric locomotives, refined during the conflict, began appearing on main lines with promises of lower operating costs and simpler maintenance. By 1950, Union Pacific was already testing EMDF units on freight runs, comparing fuel costs and crew efficiency. The big boys kept running. Through the Korean War, through the 1950s expansion, they hauled everything from coal drags to manifest freight, sometimes hitting speeds that seemed impossible for machines their size. Crews developed a respect bordering on affection for the locomotives, even as diesel switchers multiplied in the yards. But the economics were shifting. A big boy needed a fireman to shovel coal, an engineer to manage steam, and constant stops for water and fuel. A diesel locomotive could run 500 miles on a single tank, operated by a single engineer, and required a fraction of the maintenance hours. The railroad industry wasn't sentimental. The first big boys were retired in 1959. By 1962, only a handful remained in service, relegated to coal drags and occasional heavy hauls when diesel power was scarce. The last revenue run came in July 1959, a coal train from Green River to Ogden. The locomotive was 4024, and it pulled its final consist with the same tireless power it had shown 2 decades earlier. They were scrapped quickly after retirement, cut apart in the same Wyoming yards where they'd once ruled. Of the 25 built, 8 survived, preserved in museums across the country as monuments to an era when engineering ambition outpaced practical sense and somehow made it work anyway. Today, one remains operational. The 4014, restored by Union Pacific's Heritage Program, occasionally runs excursions across the same routes it worked 70 years ago. The coal smoke still pours black and thick. The ground still trembles when it passes. And for a moment, the impossible locomotive that conquered America rolls again, proof that sometimes the answer to an unsolvable problem is to build something too stubborn to fail.